Here is a stack image of Cilia, and we will use CiliaQ to measure various parameters of Cilia using ImageJ Fiji. The first step is to download and install these 6 plugins. The link to the plugins are provided in the description below. Once installed, restart the Fiji. Now head to Plugin, CiliaQ, and select CiliaQ Preparator. In this window, users can select any choice of their preference. In the Preference option, users can load a metadata if available, or manually enter their preferences. Similarly, users can choose the output image name and then click OK. In the next window, select the number of channel. In this example, the number of channel is 1. Select the first option to include a copy of the unsegmented channel. Users can also select the options to minimize the background of the image. This will allow a clear image of the cilia. There are many methods available for the segmentation method. For this tutorial, let us use Canny 3D. Adjust the stack handling if users do not use the Canny 3D segmentation. In addition, select the threshold option if using other segmentation methods. Select a segmentation style based on the image segmentation that users would require. Next, in this Canny 3D thresholder window, adjust the sigma for Gaussian blur and the alpha sensitivity for edge detection. Select a thresholding method to set a method as a lower threshold process. Alternatively, users can also choose to input the lower threshold value if the custom option is chosen in the previous step. Similarly, select the appropriate threshold method to set as a high threshold process. If the automatic threshold is not selected for this step, users can input the value instead. Now, click OK to proceed to the next step. In this Multi-File Manager window, select the image of interest. Now, click on Start Processing. Once the processing is successfully completed, the input image file will transfer from the remaining files to process column to the processed file column. Users can also find the dialog Analysis Done once the image processing is completed. The successful execution of this step will generate a text file and an image file. The text file contains the parameters used during the segmentation method. This text file also shows the segmented and the unsegmented channel as channel 1 and channel 2. This slider C shows the segmented and the unsegmented image. The G slider shows all the stack images. Next, head to Plugins and find the CiliaQ Editor plugin. In this editor window, input the segmented and the unsegmented channel numbers. Select the output image file name of your choice and then click OK. In this pop-up window, there are options to add or remove a selection in the image. For instance, if the cilia or filament is disconnected within the G stack plane due to issues arising with focusing the image, the Add selection can help to overcome the issue. In this magnified image, the cilium seems to be disconnected, although it is a part of the same cilium. Use the freehand selection tool from above and draw the region of interest just touching the edge of the cilium. Now click on Add Selection. The Remove Selection feature is used to remove any background or noise that are present in the image. To distinguish the cilia from the background staining, select the Freehand Selection tool from above and draw the region of interest around the background to be removed. Once selected, click on Remove Selection. If the selected region is an error, users can undo it, the Undo Last Editing option. This process of removing background selection is to be applied to all the individual images in the G stack. Once completed, click on Finish Analysis and Save Editing. At this time, 3 files are generated that consist of a folder, image, and a text file. This image file is the modified image that have the background removed and the cilia corrected. Now head to Plugins and then find the CiliaQ plugin. In this window, choose any of the image input method. The calibration settings can be manually performed as the image measurements can vary between images. To check voxel depth measurement, head to Image and select Properties. Once the voxel depth is noted, head to CiliaQ plugin again. Change the voxel depth values obtained accordingly. Users can also choose from the output settings as to which of the following output files are required according to the experimental results. Selecting multiple output results may increase the image processing time. For this image analysis, let us select the Measure Intensity A option. Users can also choose to detect the basal stain, if any, in their images. In the Channels option, let us input the Channel 1 and Channel 2. As we have unselected the Measure Intensity B and the basal stain under detection, therefore Channel 3 and 4 can be omitted. Adjust the minimum cilia size accordingly. Check on the increased range for connecting cilia to enhance the identification and measurement of the cilia along each cilium. Users also have the option to exclude measuring the cilia that touch the borders. Users can also select other options to increase the identification of each cilium in the image with weak intensity staining. Check on Determine skeleton-based results and then click OK. Now, select the image file that was generated by the CiliaQ editor in our earlier steps. Next, proceed with the Start Processing option. Once the processing is successfully completed, the input image file will transfer from the remaining files to the Processed Files column. At this time, the plugin has identified 50 cilia and this progress can be monitored. It might take a while to complete processing, depending on the number of cilia and the output results being processed. Once the analysis is completed, multiple images and text files are generated. This window can be closed if needed. The cq.txt file contains the parameters set for the analysis. It also shows the number of cilia excluded as well as analyzed. Now, copy this portion of the results section and paste into an Excel sheet. Next, open the text file with the name that ends with cqs.txt. This file contains the measurements of the cilia. Select all the results in this section and then copy and paste into the same Excel sheet. Now, this Excel sheet contains all the results obtained from the CiliaQ processing. Each cilium is assigned an ID number. Users can explore all the information obtained, such as cilia intensity, orientation, and length. The image file that ends with cqrp.tif contains the images of the cilia with their ID numbers assigned. Users can magnify to check which cilium has been assigned an ID number. From the Excel sheet, users can also find the X, Y, and G centers of each cilium. Thanks for watching.